On Thursday, April 30th, 1942, a test pilot climbed into the cockpit of an American fighter at a Royal Air Force base in Cambridgeshire, England. He was not scheduled to fly that day. He had driven to the airfield with his wife, curious to see this new aircraft the Americans had built for Britain. The flight lasted approximately 30 minutes. When he landed, he knew immediately that he had just flown something extraordinary, something that could change the entire course of the air war over Europe. But there was a problem. The aircraft was crippled by an engine that choked and gasped above 15,000 feet, leaving it unable to fight where the real battles raged. That test pilot's name was Ronald Harker. He worked for Rolls Royce, and the memo he wrote the very next day would set in motion one of the most consequential decisions in aviation history. An engine swap, a marriage of American engineering brilliance and British powerplant supremacy. The result would be an aircraft that flew all the way to Berlin and back, that broke the spine of the Luftwaffe, and that many historians credit with winning the air war over Europe. This is the story of how one simple modification turned a good airplane into a war winner. The aircraft Ronald Harker flew that spring afternoon was the North American P-51 Mustang. It had been born 2 years earlier from an audacious promise and an impossible deadline. In February 1940, with Britain standing virtually alone against Nazi Germany, the British Purchasing Commission approached an American aircraft manufacturer called North American Aviation. The British needed fighters desperately. They asked North American to build Curtiss P-40 Tomahawks under license, an established design that could enter production quickly. But James Kindleberger, the president of North American Aviation, had a different idea. His company had never designed a fighter aircraft. They built trainers, reliable and profitable, but hardly glamorous. Yet Kindleberger believed his chief designer could create something far better than the P-40. That designer was Edgar Schmued, an Austrian-born engineer who had been quietly sketching fighter concepts for months, waiting for exactly this opportunity. Schmued was 40 years old in 1940. He had been born in Hornbach, Bavaria, served as an aviation mechanic in the Austro-Hungarian forces during the First World War, emigrated to Brazil in 1925, and eventually made his way to the United States through General Motors aviation subsidiaries. He was a self-taught engineer with an intuitive grasp of aerodynamics that formal education could not have improved. When Kindleberger asked if North American could design a better fighter than the P-40, Schmued's response was immediate and characteristically blunt. He said they should not build an obsolete aeroplane when they could design a new one, a better one. The British agreed, but they imposed an almost impossible condition. They wanted a flyable prototype within 120 days. The British Purchasing Commission accepted North American's proposal in early April 1940. Work began under a letter of understanding on May 1st, and the formal contract was signed on May 23rd. It specified 320 aircraft designated NA-73. The price was set at $40,000 per airframe, not including government-furnished equipment like engines, propellers, and armament. Schmued assembled a small, ferocious team of engineers. The pressure was enormous. Britain stood alone against Nazi Germany after the fall of France. Every week that passed without adequate fighter aircraft was another week that the Luftwaffe bombed British cities and shipping with near impunity. The team understood that their work had immediate, life-or-death consequences. Raymond Rice served as chief engineer. Ed Hawkey led the aerodynamics work. Larry Waite and Art Chester filled crucial supporting roles. They worked late into every night, going home early only on Sundays, and even then not until 6 in the evening. Their design incorporated 2 revolutionary features that would define the Mustang's extraordinary performance. The wing used laminar flow airfoils developed cooperatively with the National Advisory Committee for Aeronautics. Traditional airfoils placed their thickest point about 1/3 of the way back from the leading edge. Schmued's wing moved that point 2/3 of the way back, dramatically reducing drag at high speeds. The second innovation was equally clever. The ventral radiator scoop beneath the fuselage exploited something called the Meredith effect. Air entering the scoop was heated by passing through the radiator, then expelled rearward through a convergent duct. This heated cooling air expanded and accelerated, actually producing a small amount of thrust that partially offset the drag caused by the cooling system itself. The combined effect of these innovations gave the Mustang a drag coefficient of 0.0163, significantly lower than any contemporary fighter aircraft. The prototype, designated NA-73X, rolled out of the Inglewood, California factory on September 9, 1940. They had done it in 102 days, 18 days ahead of schedule, but the airframe sat engineless on the tarmac. The power plant had not yet arrived. When the Allison V 1710 finally reached Inglewood roughly 18 days later, the engine had been modified from its original specifications, forcing North American to fabricate entirely new motor mounts. Test pilot Vance Breeze made the first flight on October 26, 1940, from Mines Field in Los Angeles. The aircraft performed beautifully. It was fast, maneuverable, and handled like a dream at low altitude. The British were impressed. They ordered more. But hidden within that successful first flight was a fatal flaw that would nearly consign the Mustang to historical obscurity. The Allison V 1710 was the only American-produced liquid-cooled 512 engine in mass production at the time. It was a robust and reliable 28-litre power plant that generated 1,150 horsepower at takeoff. The engine had been under development since 1930 at the Allison Engine Company in Indianapolis, Indiana. It represented a massive investment in American aviation capability. The same engine powered the P-38 Lightning, the P-39 Airacobra, and the P-40 Warhawk. It was proven technology, battle-tested over North Africa, the Pacific, and the skies of Europe. But the United States Army Air Corps had specified that the Allison be built with only a single-stage, single-speed supercharger. This was not an oversight or a failure of imagination. American military planners expected turbo superchargers to be added for high-altitude operations. General Electric manufactured these devices, which compressed incoming air using exhaust gas-driven turbines. They were classified technology, strictly forbidden for export to any foreign nation, even allies. Since the Mustang was built specifically for British export, the turbo supercharger was unavailable. The consequence was devastating for high-altitude performance. The Allison maintained its power adequately up to about 12,000 feet. Above that altitude, power dropped off rapidly as the thin air starved the engine of oxygen. At 25,000 feet, where European air combat typically raged, the Allison-powered Mustang was badly outclassed by German fighters. The same aircraft that had demonstrated such promise at low altitude became sluggish and underpowered in the combat environment that actually mattered. The Royal Air Force recognized both the brilliance of the airframe and the limitation of the engine. They made a practical decision. Rather than assign the Mustang to Fighter Command for air-to-air combat, they sent it to Army Cooperation Command for low-altitude tactical reconnaissance. The aircraft would replace aging Westland Lysanders and Curtiss Tomahawks, flying missions that kept them below the altitude where the Allison engine failed. Number 26, Squadron at Gatwick received the first Mustang aircraft in January 1942. Flying Officer G.N. Dawson flew the type's first combat mission on May 10, 1942, strafing hangars and shooting up a train near Berck-sur-Mer in France. On July 27, 1942, 16 RAF Mustangs flew the first Allied single-seat fighter reconnaissance mission over Germany since 1940. The aircraft proved extraordinarily effective in this role. The Allison engine ran smoothly at just 1,100 revolutions per minute, compared to 1,600 for the Merlin engine in Spitfires. This allowed Mustang pilots to fly long missions at treetop height with excellent fuel economy. During the Dieppe raid on August 19, 1942, 4 British and Canadian Mustang squadrons supported the operation. Flying Officer Hollis Hills of No. 414 Squadron Royal Canadian Air Force scored the first Mustang air-to-air victory that day, shooting down a Focke-Wulf 190. In its first 18 months of RAF service, the Mustang destroyed or damaged 200 locomotives and over 200 canal barges for the loss of only 8 aircraft. These were not trivial targets. Locomotives were essential to German logistics, moving troops, ammunition, and supplies throughout occupied Europe. Destroying them created cascading effects across the entire German war machine. The canal barges carried coal, iron ore, and other industrial materials that German factories desperately needed. Each barge destroyed represented tons of material that would never reach German production lines. At low altitude, the Allison Mustang was 30 miles per hour faster than the P-40, using exactly the same engine. This demonstrated conclusively that Schmued's aerodynamic innovations were real and significant. The airframe was clearly something special. Everyone who flew it recognized that immediately. Squadron commanders wrote enthusiastic reports. Pilots requested assignment to Mustang units. Maintenance crews appreciated the aircraft's reliability and accessibility. But the aircraft remained confined to hedge-hopping reconnaissance missions, while the great air battles of 1942 and 43 raged miles above its operational ceiling. The Mustang needed a different heart. It needed an engine that could breathe in the thin air above 20,000 feet. It needed the Merlin. This brings us back to that April morning at RAF Duxford in 1942. The Air Fighting Development Unit had been evaluating the Mustang since January. Wing Commander Ian Campbell Ord commanded the unit. He invited Ronald Harker, Rolls-Royce's senior liaison test pilot, to fly the aircraft during an informal visit. Harker climbed into the cockpit, took off, and spent approximately 30 minutes exploring the Mustang's handling characteristics. He was astonished by what he found. The aircraft was faster, more responsive, and more aerodynamically refined than anything he had expected. When he landed, his mind was already racing with possibilities. The next day, May 1st, 1942, Harker wrote a brief memorandum to Rolls-Royce Managing Director A.F. Sidgreaves and Works Manager Ernest Hives. He noted that the Mustang could prove itself a formidable low- and medium-altitude fighter. He observed that it closely resembled the Messerschmitt 109F in general configuration. Then he made the suggestion that would change aviation history. He wrote that with a powerful and good engine like the Merlin 61, the Mustang's performance could be outstanding because it was already 35 miles per hour faster than the Spitfire Mark V at roughly the same power level. Harker immediately telephoned Ray Dorey, head of Rolls-Royce's experimental division at Hucknall. Within 48 hours, Dorey had consulted with Ernest Hives, who authorized the project. Hives put the proposal to Air Chief Marshal Sir Wilfrid Freeman, Vice Chief of the Air Staff. Freeman became a vigorous champion of the idea. Rolls-Royce's chief aerodynamic engineer, Witold Chalier, ran the performance calculations. His predictions proved remarkably accurate. The Merlin 20 would yield approximately 400 miles per hour. The two-stage, two-speed Merlin 61 would yield 441 miles per hour at 25,600 feet. The difference was staggering. The same airframe that struggled above 15,000 feet would suddenly become competitive at 40,000 feet. Rolls-Royce began converting 5 Mustang airframes at their Hucknall facility, designating them Mustang X. The conversion was not a simple bolt-on procedure. The Merlin engine was physically different from the Allison, requiring modifications to the engine mounts, cowling, and accessory drives. The intercooler for the supercharger needed integration with the existing cooling system. The propeller shaft was at a different angle, requiring nose gear adjustments. Electrical systems needed modification to accommodate British equipment. Rolls-Royce engineers worked around the clock to complete the conversions as quickly as possible. The first conversion, serial number AL975, was fitted with a Merlin 65 engine and a 4-bladed Rotol propeller. The Merlin 65 was a derivative of the famous Merlin 61 that powered the Spitfire Mark IX. It featured a 2-stage, 2-speed supercharger that maintained power at high altitudes where single-stage superchargers faltered. The 2-stage design compressed air twice before feeding it to the engine, dramatically increasing the oxygen available for combustion at thin air altitudes. Captain R.T. Shepard, Rolls-Royce's chief test pilot, flew it for the first time on October 13, 1942. The results electrified everyone involved. The converted aircraft, designated AM-208, reached 433 miles per hour at 22,000 feet. Aircraft AL975 achieved an absolute ceiling of 40,600 feet. These numbers were extraordinary. For comparison, the Spitfire Mark V had a service ceiling of approximately 36,000 feet. The Messerschmitt 109F could reach about 39,000 feet. The Mustang, the same airframe that had been confined to treetop-level strafing and reconnaissance, could now fight effectively in the stratosphere. The engine swap had worked beyond anyone's most optimistic expectations. Test pilots reported that the aircraft handled beautifully at all altitudes, with no significant trim changes as speed or altitude varied. The Meredith effect radiator design proved even more effective with the higher power Merlin, generating measurable thrust at high speeds. Ronald Harker was not technically the first person to suggest putting a Merlin engine in the Mustang. As early as April 1941, Richard Fairey of the British Air Commission had inquired about the possibility. Representatives from the aeroplane and armament experimental establishment had made similar suggestions that went nowhere, but Harker was the man who made it actually happen. He had the right combination of technical credibility, institutional connections, and sheer persistence to push the idea through bureaucratic resistance. His reward from Rolls Royce was characteristically modest. They gave him a pay rise of £1 per week. He later became known as the man who put the Merlin in the Mustang. He flew his last Mustang flight in 1997 at age 88 during a New Zealand air display. He died on May 30th, 1999, at Taupo, New Zealand, a town he had chosen for retirement because of its excellent trout fishing. But proving the concept in Britain was only half the battle. The real obstacle was bureaucratic. The United States Army Air Forces showed almost no interest in the Mustang. It was, after all, a British-ordered aircraft with no institutional champion in the American military establishment. The Army Air Forces had not specified its design, had not funded its development, and felt no particular ownership over its success or failure. Enter Lieutenant Colonel Thomas Hitchcock, Jr., a man whose biography reads like the screenplay of an adventure film. Hitchcock was born in 1900 in Aiken, South Carolina. He became a 10-goal polo player, the sport's highest ranking, and maintained that status from 1922 to 1940. But polo was merely his hobby. During the First World War, he served as a pilot in the Lafayette Flying Corps, scoring aerial victories at age 17. He was shot down and captured by the Germans. He escaped by jumping from a moving German prison train and walking over 100 miles across 8 nights until he reached Switzerland. He attended Harvard and Oxford, became a partner at Lehman Brothers, and was so charismatic that F. Scott Fitzgerald modelled characters on him in both The Great Gatsby and Tender is the Night. Fitzgerald wrote that Hitchcock was high in his personal pantheon of heroes. When the Second World War began, Hitchcock volunteered as a fighter pilot at age 41. General Henry Arnold rejected him as too old for combat flying. Instead, Ambassador John Winant brought Hitchcock to London as assistant military attaché for air. There, he learned about the Rolls Royce Merlin conversion project at Hucknall and immediately grasped its significance. His assessment of the Mustang's orphan status cut directly to the heart of the problem. He observed that the aircraft had been sired by the English out of an American mother, and therefore had no parent in the Army Air Corps to appreciate and push its good points. That had to change. Hitchcock decided to make himself that parent. In November 1942, Hitchcock flew to Washington and went straight to his old friend Robert Lovett, who served as Assistant Secretary of War for Air. Lovett agreed with Hitchcock's assessment and pressed General Arnold to take the Merlin Mustang seriously. Arnold, whose strategic thinking centered on heavy bombers rather than escort fighters, was initially reluctant, but Lovett was one of his civilian superiors, and the pressure was impossible to ignore. Arnold ordered approximately 2,200 P-51B aircraft, an extraordinary commitment given that no American-built Merlin Mustang had even flown when the initial order for 400 was placed in August 1942. The word channels, like the word no, was an utterance Hitchcock sometimes could not hear well, his biographer later noted. Tragically, Hitchcock did not live to see the full vindication of his advocacy. On April 18, 1944, while personally test flying a P-51 to investigate reports of uncontrollable dives related to external fuel tank instability, his aircraft crashed near Salisbury, England. He was killed at age 44, just 7 weeks before D-Day. Ambassador Winant wrote afterward that the Mustang was tangible evidence of Tommy's contribution to victory, and that without it, the Allies would not be winning the air war over Germany. The National World War II Museum states that perhaps no single individual had a greater influence over the development and adaptation of the P-51 Mustang than Tommy Hitchcock. The parallel American conversion effort at North American Aviation moved with remarkable speed. On July 25, 1942, North American was authorized to convert 2 Mustangs to Merlin power, designated NA-101. These aircraft were initially called XP-78, later redesignated XP-51B. The American conversion was more thorough than the British Mustang X project. North American completely redesigned the engine cowling, strengthened the airframe to handle the Packard V 1653's extra 355 pounds, redesigned the radiator duct, and replaced the 3-blade Curtiss electric propeller with a 4-blade Hamilton standard unit. The first XP-51B flew on November 30th, 1942, just weeks after the British Mustang X. The engine that would power America's Mustangs came from the Packard Motor Car Company of Detroit. In July 1940, Henry Ford had offered to manufacture Merlin engines at his vast River Rouge complex, but then backed out, stating he would only build for American defense, not for Britain. Ford's decision disappointed British officials, but it opened the door for Packard. The contract went to Packard instead, and in retrospect it was probably a better choice. Rolls-Royce was impressed by Packard's precision engineering heritage, their experience building luxury automobiles to exacting tolerances. Packard had earned a reputation as one of America's finest manufacturers, producing cars that competed with Rolls-Royce itself in quality and craftsmanship. The company invested heavily in new machine tools and trained workers to meet Rolls-Royce specifications, which were among the most demanding in the world. British engineers travelled to Detroit to supervise the initial setup and ensure quality standards were maintained. The first Packard-built Merlin, designated V1651, was a single-stage variant for the P-40F Warhawk. It ran in August 1941. The crucial two-stage, two-speed V1653, equivalent to the British Merlin 63, began rolling off production lines in mid-December 1942. This engine generated 1,380 horsepower at sea level and maintained its power above 30,000 feet, where the Allison had gasped and failed. Packard engineers actually improved upon the British original in several ways, changing the main crankshaft bearings to a silver-lead combination with indium plating that proved more durable under sustained high-power operation, and adopting a modified supercharger drive. These improvements were shared back with Rolls-Royce and incorporated into later British production. Total American Merlin production eventually reached over 55,000 engines, a testament to American industrial capacity and Packard's manufacturing excellence. The first production, P-51B, rolled off the Inglewood assembly line and flew on May 5, 1943. By November 1st of that year, the 354th Fighter Group, nicknamed the Pioneer Mustangs, arrived in England with the first operational Merlin Mustangs. The performance transformation was staggering. The Allison-powered P-51A had achieved a maximum speed of 390 miles per hour at 20,000 feet. The Merlin-powered P-51B reached 441 miles per hour at 30,000 feet. Service ceiling climbed from approximately 31,000 feet to nearly 42,000 feet. Time to climb to 20,000 feet dropped from 9 minutes to under 6 minutes. Most importantly, combat radius with external fuel tanks expanded from roughly 400 miles to 750 miles. The Mustang could now escort bombers all the way to Berlin and back, something no other single-engine fighter in the Allied inventory could accomplish. The Mustang's fuel efficiency gave it an insurmountable range advantage over every other American fighter. It achieved approximately 3.3 miles per gallon compared to the P-47 Thunderbolt's 1.8 miles per gallon. This was not a marginal difference. It was a war-winning capability. With two 108-gallon drop tanks fitted beneath its wings, a P-51D could fly approximately 1,650 miles. The P-47 maxed out at roughly 850 miles. The P-38 Lightning had theoretical range, but suffered chronic engine reliability problems in the cold, damp conditions of European operations. The Mustang could go where other fighters simply could not follow. The 354th Fighter Group flew its first P-51B combat mission on December 1, 1943, a fighter sweep over the Saint-Omer and Knock area of Belgium and France. 23 aircraft participated, led by Lieutenant Colonel Don Blakesley. Escort missions pushed progressively deeper into enemy territory over the following weeks. Amiens, Emden, Kiel. On January 11, 1944, Major James Howard of the 354th Fighter Group earned the only Medal of Honor awarded to a P-51 pilot in the European theater. Left alone after his flight scattered during an escort mission, Howard single-handedly fought off 30 or more German fighters attacking B-17 bombers near Oschersleben for over 30 minutes. He shot down 3 confirmed, and probably 5 more. When his ammunition ran out, he continued making aggressive passes to bluff the enemy away from the bombers. A B-17 crewman radioed afterward, asking who that lone fighter pilot had been. The real revolution in how the Mustang was employed came when Major General James Doolittle took command of the 8th Air Force in January 1944. Upon visiting 8th Fighter Command headquarters, Doolittle noticed a sign on the wall that read that the first duty of 8th Air Force fighters was to bring the bombers back alive. He told his subordinate to take it down immediately. A new sign went up. It stated that the first duty of 8th Air Force fighters was to destroy German fighters. Doolittle later called this the most important and far-reaching military decision he made during the entire war. The change was profound. Instead of staying close to the bomber formations in a purely defensive posture, fighters were released to range freely, sweeping 50 miles ahead of the bombers to catch German interceptors on the ground or as they formed up to attack. The bombers became bait to draw the Luftwaffe into a fight it could not win. On March 4, 1944, Colonel Blakesley led the 4th Fighter Group's brand-new P-51B aircraft on the first single-engine fighter escort mission to Berlin. The mission was considered extremely risky. Some pilots had less than 1 hour of experience in the type. Many had transitioned from P-47s just days before. The round trip covered 1,100 miles through heavily defended airspace. Blakesley himself had extensive combat experience, having flown Spitfires with the RAF before America entered the war and Thunderbolts after. He pushed relentlessly for the transition to Mustangs, understanding that only the P-51 had the range to escort bombers to the most critical targets. The mission was a success. The Mustangs reached Berlin, engaged German interceptors, and returned to England. 2 days later, on March 6th, the first major daylight bombing raid on Berlin sent over 800 bombers, escorted by more than 900 fighters, including 121 P-51s. The Luftwaffe rose to defend the Reich capital in force. Fierce air battles raged across the skies of central Germany. 69 bombers were lost that day, a loss rate of 9.4%. The toll was heavy. Hundreds of American airmen were killed, wounded, or captured. But the strategic message was unmistakable. The Luftwaffe could no longer defend the Reich capital in daylight. American fighters could now reach any target in Germany and fight effectively when they arrived. The psychological impact on German civilians and military planners was profound. If Berlin itself could be bombed in broad daylight, nowhere in Germany was safe. Operation Argument, better known as Big Week, was flown from February 20th through February 25th, 1944. For 6 consecutive days, weather permitting, Allied bombers hammered German aircraft factories with over 3,300 bomber sorties. The targets included plants at Leipzig, Regensburg, Augsburg, Stuttgart, and other industrial centers. RAF Bomber Command flew complementary night raids against the same target complexes. The combined offensive represented the most concentrated aerial assault of the war to date. The P-51, though outnumbered by P-47s in the escort force, shot down more Luftwaffe aircraft per plane than any other fighter type participating. Mustang pilots reported that German pilots seemed surprised to encounter American fighters so deep in German airspace. Many enemy aircraft were caught while still climbing to attack altitude, vulnerable and unable to maneuver effectively. But the real damage was not to German factories. Through dispersal and reorganization, German fighter production actually peaked in 1944. The irreplaceable loss was experienced pilots. Approximately 100 veteran German fighter pilots were killed during Big Week alone, representing roughly 14% of the experienced force. These men had hundreds of combat sorties between them. They knew how to survive in aerial combat, how to attack bombers effectively, how to evade Allied fighters. Their knowledge and skill could not be replaced by classroom instruction. The pilots who replaced the fallen veterans had fewer flying hours, less combat experience, and correspondingly lower survival rates against battle-hardened American opponents. Many new German pilots had as little as 80 hours total flying time before assignment to operational squadrons. Their American counterparts typically had 300 hours or more. The attrition spiral had begun, and it would prove impossible to reverse. The P-51 produced a remarkable gallery of aces, each with stories worthy of extended telling. George Preddy became the top-scoring Mustang ace with 26.83 aerial victories. He was a 120-pound native of Greensboro, North Carolina, rejected 3 times by the Navy for his small stature before the Army Air Forces accepted him. On August 6, 1944, nursing a hangover from a war bond party the night before, Preddy led a bomber escort mission over Hamburg. He spotted approximately 60 Messerschmitt 109s attacking from below. The German pilots had not noticed the P-51 escorts above them. Preddy dove onto the rear of the enemy formation and shot down 6 Messerschmitt 109s in approximately 5 minutes, becoming one of only 38 Army Air Forces pilots to become an ace in a single day. On Christmas Day, 1944, during the Battle of the Bulge, Preddy pursued a Focke-Wulf 190 to treetop level near Liège in Belgium. An American anti-aircraft battery, firing at the German aircraft, hit Preddy's Mustang instead. A .50 caliber bullet severed his femoral artery. He was 25 years old. His younger brother William, also a fighter pilot, was killed in action 4 months later in April 1945. They are buried side by side at Lorraine American Cemetery in Saint-Avold, France. Clarence Anderson, known universally by his nickname Bud, flew 116 combat missions with the 357th Fighter Group in his P-51 named Old Crow. He told church-going friends the name honored the smartest bird in the sky, though his drinking companions knew it actually referred to the cheap bourbon whiskey. Anderson's combat record was extraordinary. He scored 16.25 aerial victories, and his aircraft was never hit by enemy fire across all 116 sorties. He never turned back from a mission for any reason. His ground crew was fiercely dedicated. After Anderson casually mentioned that bare metal aircraft seemed to blend better against the winter sky, his maintenance team stayed up through an entire night, hand-stripping paint from Old Crow with gasoline-soaked rags. Their hands were chafed raw by morning. Anderson lived to age 102, dying on May 17, 2024, as the last living American triple ace of the Second World War. Colonel John Meyer of the 352nd Fighter Group scored 24 aerial victories and became the only Air Force officer awarded the Distinguished Service Cross 3 times. His most dramatic moment came on New Year's Day, 1945, during Operation Bodenplatte, the Luftwaffe's last great offensive. Approximately 50 Focke-Wulf 190s attacked his airfield at Asch in Belgium. Meyer's foresight in having aircraft pre-flighted and ready to scramble saved the day. He shot down a Focke-Wulf 190 before his landing gear was even retracted after a hasty takeoff, then led a 45-minute running battle that ended with the 352nd scoring 23 kills for 0 losses. It was a complete rout of Jagdgeschwader 11. Don Gentile and John Godfrey of the 4th Fighter Group were known as the Two-Man Air Force, accounting for over 58 enemy aircraft destroyed between them. On March 8, 1944, over Berlin, the pair attacked approximately 50 enemy fighters, assaulting the bomber formation with only each other for support. Gentile scored half his total kills during March 1944 alone, the hottest month of the air war over Europe. By Victory in Europe Day in May 1945, P-51 groups of the 8th, 9th, and 15th Air Forces had claimed 4,950 enemy aircraft destroyed in the air and approximately 4,131 on the ground. These figures represented roughly half of all Army Air Forces claims in the European theatre. The Mustang had proven itself not only in air-to-air combat but also as a devastating ground attack aircraft, strafing enemy airfields, rail yards, convoys, and troop concentrations. North American Aviation produced approximately 15,586 Mustangs across all variants at its Inglewood, California, and Dallas, Texas plants. The Inglewood facility alone employed over 40,000 workers at peak production. Peak output reached more than 850 aircraft per month by January 1945, an astonishing rate that reflected the maturity of American wartime manufacturing. The definitive P-51D, with its bubble canopy providing 360-degree visibility and 650 caliber machine guns with improved ammunition feed mechanisms, accounted for over 8,100 of the total. Each P-51 D cost approximately $50,985, barely 60%, the price of a P-47 Thunderbolt at $83,000, and roughly half that of a P-38 Lightning at approximately $100,000. The Mustang delivered superior performance at lower cost, a combination that made it the obvious choice for fighter group commanders. By the end of 1944, 14 of 15 8th Air Force fighter groups flew Mustangs. The lone holdout was the 56th Fighter Group, Zemke's Wolfpack, which retained its P-47s until the end of the war and remained the highest-scoring 8th Air Force fighter group in air-to-air combat. The bomber loss statistics tell the strategic story most starkly. During the second Schweinfurt raid on October 14, 1943, before the Merlin Mustang arrived in significant numbers, 60 of 291 B-17 bombers dispatched were shot down. This represented a battle loss rate of 20.6%, a rate that would have destroyed the 8th Air Force as an effective fighting force if sustained. The Luftwaffe lost only 38 aircraft defending that day. By February 1944, with P-51s arriving in force, bomber losses fell to 3.5%. Average monthly heavy bomber loss rates dropped from 5.1% in 1943 to 1.9% in 1944. Battle damage to surviving aircraft fell from 45.6% to under 30%. The impact on the Luftwaffe was catastrophic and irreversible. German fighter pilot losses accelerated throughout 1944. In January, they lost approximately 1,000 pilots killed, wounded, or captured. In February, during Big Week, losses spiked dramatically as the most intense air battles of the war raged over Germany. March brought the Berlin raids and further attrition. April, May, and June saw continuous combat as Allied forces prepared for the invasion of France. By May, the Luftwaffe was losing pilots faster than it could train replacements, even at reduced standards. Fuel shortages compounded the crisis. Allied bombing targeted synthetic fuel plants and oil refineries with increasing effectiveness. German aviation fuel production fell by 90% between May and September 1944. Training programs were cut to preserve fuel for combat operations. New German pilots received fewer and fewer training hours before being thrown into combat against experienced American and British opponents. Many were killed on their first or second missions, having never fired their guns in anger before encountering a flight of P-51s. The handful of expert pilots who survived carried an ever-increasing burden, flying multiple sorties per day until exhaustion, injury, or death caught up with them. Pilots like Erich Hartmann and Gerhard Barkhorn accumulated hundreds of victories, but even their exceptional skills could not compensate for the steady erosion of Luftwaffe strength. By D-Day, on June 6, 1944, the once fearsome Luftwaffe could muster only approximately 70 single-engine fighter sorties against the invasion beaches, while the Allies flew over 14,000 sorties that day. German pilots who attempted to intervene were overwhelmed by sheer numbers. Allied air supremacy was complete, and it would remain so for the rest of the war. Hermann Göring, commander of the Luftwaffe, reportedly said upon seeing Mustangs over Berlin that he knew the war was lost. Historians debate the exact provenance and precise wording of this quote, but its essential sentiment is beyond question. The appearance of American single-engine fighters over the German capital, fighters that could fight effectively and still return to England, represented a strategic inflection point from which the Third Reich never recovered. The United States Army Air Force's own official history later conceded that the initial neglect of the Mustang came close to representing the costliest mistake made by the Army Air Forces in the Second World War. That it became instead the war's greatest success story testified to the handful of individuals who saw what was possible and refused to accept any answer but yes. The Mustang's dominance extended beyond Europe. In the Pacific Theater, P-51s flew long-range escort missions from Iwo Jima to Japan beginning in April 1945. The island of Iwo Jima, captured at terrible cost in February and March of that year, provided an essential base for fighter operations against the Japanese home islands. P-51s of the 7th Fighter Command escorted B-29 superfortresses on strikes against Japanese industrial targets, providing protection during the final approach when the bombers were most vulnerable. They also conducted their own strafing attacks on Japanese airfields, destroying aircraft on the ground before they could rise to intercept. These missions required exceptional endurance and navigation skill, covering over 1,500 miles of open ocean with no landmarks and no margin for error. The aircraft proved equally effective against Japanese opposition, though the air-to-air combat was less intensive than over Europe by that late stage of the war. Japanese aviation had been devastated by attrition and fuel shortages, much like the Luftwaffe before it. After the Second World War ended, the Mustang continued serving in conflicts around the world. It flew combat missions during the Korean War from 1950 to 1953, primarily in the ground attack role, as jet fighters like the F-86 Sabre took over air superiority duties. The Mustang's range, payload capacity and reliability made it well suited for close air support and interdiction missions against North Korean and Chinese forces. Several air forces continued operating Mustangs into the 1960s and 70s, a testament to the aircraft's fundamental soundness of design. The Dominican Air Force flew Mustangs until 1984, nearly 44 years after the prototype first flew. Today, the P-51 Mustang remains one of the most iconic aircraft in aviation history. Approximately 150 airworthy examples still fly at air shows around the world. The distinctive sound of the Merlin engine, its 12-cylinder growl rising to a howl, draws crowds wherever Mustangs perform. Museums on every continent display preserved examples. The National World War II Museum in New Orleans, the Imperial War Museum at Duxford in England, the Smithsonian National Air and Space Museum in Washington all maintain Mustangs as centerpieces of their collections. The aircraft represents not just a technical achievement, but a turning point in the greatest conflict in human history. The story of the P-51 Mustang is ultimately a story about recognizing potential and having the courage to act on that recognition. Edgar Schmued saw the potential in laminar flow aerodynamics and the Meredith effect. Ronald Harker saw the potential in mating that brilliant airframe to the Merlin engine. Tommy Hitchcock saw the potential to change American military doctrine and burned through his social capital to make it happen. James Doolittle saw the potential to use the Mustang not as a defensive escort, but as an offensive weapon to seek out and destroy the Luftwaffe wherever it could be found. Each of these men looked at the same facts that others had seen and drew conclusions that others had missed. Each pushed against institutional resistance and prevailing orthodoxy. Each was vindicated by results that exceeded even optimistic expectations. The Merlin Mustang did not win the Second World War by itself. Victory required the combined efforts of millions of soldiers, sailors, airmen, and civilians across dozens of nations. It required the sacrifice of hundreds of thousands of lives and the expenditure of industrial resources on a scale never seen before or since. But the P-51 Mustang, transformed by an engine swap that nearly did not happen, gave the Allies something they desperately needed at a critical moment. It gave them control of the skies over Europe. It allowed the strategic bombing campaign to continue and intensify. It destroyed the Luftwaffe's ability to contest Allied operations. It made D-Day possible by ensuring that the invasion beaches would not be dominated by German aircraft. It shortened the war and saved countless lives that would have been lost in a longer, more attenuated conflict. When Ronald Harker climbed out of that Mustang cockpit at Duxford in April 1942, he knew he had flown something special. But even he could not have imagined where that 30-minute flight would lead. A one-page memo, an engine conversion project, a bureaucratic battle waged by a polo playing war hero, a production program that built over 15,000 aircraft, a campaign that broke the back of the world's most feared air force, a legacy that endures 8 decades later. The P-51 Mustang, born from a 102-day design sprint, nearly abandoned as a tactical reconnaissance aircraft limited to hedge-hopping missions, became the fighter that escorted bombers to Berlin and back, that destroyed nearly 5,000 enemy aircraft in air-to-air combat, that transformed the strategic air war from a costly stalemate into an Allied victory. One American airframe, one British engine, one war-winning combination. This is how engineering brilliance, persistent advocacy, and strategic vision combined to change history. This is how one engine swap turned a good airplane into the fighter that won the air war over Europe.